Okay, let's dive right into this. Welcome to The Explainer. Today, we're embarking on a journey into the secret, absolutely vital conduit hidden deep inside the human thigh. It's kind of this piece of anatomical infrastructure that you probably never even think about, yet it's doing incredibly heavy lifting for your mobility every single day. We're looking at the anatomy and the immense clinical significance of the adductor canal.
So what hidden tunnel in your thigh actually keeps your lower leg alive? It sounds a bit dramatic, but it is entirely accurate. We take walking, running, standing, all of it completely for granted. But for literally any of those movements to happen, oxygen-rich blood and vital nerve signals must safely navigate from the core of your body all the way down past the knee. And to do that, they have to pass through a very specific, highly protected hidden infrastructure right in the middle of your leg.
So let's get into what and where this actually is. The adductor canal, which, by the way, you might also hear called the subsartorial canal, is an intermuscular passage. Geographically speaking, it's situated right on the medial aspect of the middle third of your thigh. Buried deep beneath the sartorius muscle, it acts as this critical transit route connecting the femoral triangle up top down to the popliteal fossa. It is quite literally the anatomical highway connecting the top half of your leg to the bottom half.
Section 1. Building the canal walls. To really understand how this highway operates, we need to look at its architecture and see exactly how the boundaries of this biological tunnel are constructed.
Now, what's really interesting here is how the boundaries are perfectly mapped out by the surrounding muscles. This canal isn't made of bone, right? It's an intramuscular space. The posterior wall is formed by the adductor magnus. Moving outward, the lateral wall is built by the vastus medialis, which is one of your quadriceps. And finally, closing the whole thing off anteromedially, we have the sartorius muscle and its fascia just draped right over it, which actually explains that alternate name we saw earlier, the subsartorial canal. It literally means beneath the sartorius. Basically, these three muscular walls come together to form this precise, triangular prism-like tunnel.
Moving on to Section 2, Essential Transit, the contents. Now that we've built the walls, what kind of vital traffic actually relies on this specific route?
Well, the adductor canal is absolutely packed with vital neurovascular structures. You've got the femoral artery bringing fresh oxygenated blood down, and right alongside it, ascending back up through the canal, is the femoral vein bringing deoxygenated blood back. But it's not just plumbing, it's wiring too. We have the saphenous nerve, as well as the nerve to the vastus medialis, which is a key motor branch, and finally, running quietly alongside all these vessels are the deep lymph vessels. Every single piece of this infrastructure is absolutely critical for the survival and the function of your lower leg.
I want to really single out the heavy hitter in this tunnel, though, the femoral artery. This is your main supplier of blood to the lower limb. It enters the canal from the femoral triangle above, travels down this highly protected sleeve, and then it does something pretty fascinating. It actually leaves the front of the thigh by passing directly through a small opening in the adductor magnus muscle. And once it passes through that opening and reaches the back of the knee, it gets a name change. It transforms into the popliteal artery. Same exact vessel, new territory, new name. Right alongside that artery is the saphenous nerve, which is a branch of the femoral nerve. And what I absolutely love about this detail is the actual physical navigation happening in such a tight space. Within the confines of the adductor canal, the saphenous nerve actually crosses over the femoral artery. It performs this delicate crossing maneuver safely within the tunnel before it eventually emerges on the medial side of the knee. It's like this highly coordinated, perfectly choreographed anatomical dance.
Which brings us to Section 3, when arteries get blocked. We've got this perfect bustling highway system, but what happens when a physiological traffic jam pops up?
Well, this leads us to a major clinical condition related to the adductor canal, known as intermittent claudication. This essentially presents as ischemic pain that strikes while you're walking, but miraculously resolves when you rest. It happens due to the gradual narrowing or occlusion of the femoral artery right inside this canal, most often driven by atherosclerosis. Think about it. When you walk, your leg muscles demand more oxygen. But because the artery in the canal is narrowed, the blood flow simply cannot keep up with that demand. And the result? Severe cramping pain.
Section 4. The collateral circulation detour. Now, a blocked artery sounds dire, but this is where you just have to marvel at the sheer genius of human biology. Because your body, it actively builds a detour. We call this clever detour collateral circulation. The really key factor here is the gradual nature of atherosclerosis. Because it's a slow process, the gradual occlusion of that main femoral artery buys your body time. It gives these smaller side street blood vessels, the collateral vessels, the necessary time to dilate and expand. Specifically, the body starts rerouting blood through the perforating branches of the profunda femoris artery. It also taps into various articular and muscular branches from both the femoral and popliteal arteries. Your body literally widens the back roads to completely bypass the main highway closure and keep that circulation going to the lower leg. It's wild.
Let's move to Section 5, Danger of Sudden Blockage. We have to contrast that incredible adaptation with a much more terrifying worst-case scenario. What if the roadblock is sudden?
There's a really stark difference in the physical outcomes depending entirely on speed. With a gradual occlusion, the body has time to react, right? Those collateral vessels dilate and circulation is miraculously maintained. But consider a sudden occlusion, say from a clot or a surgical ligature. When that blockage is immediate, those tiny side street vessels just do not have the time they need to enlarge. The detour is closed before it can even be built.
So the crucial point is, without that time to adapt, oxygenated blood stops reaching the lower leg entirely, and the tissue begins to die, resulting in gangrene. It's a dire consequence that absolutely hammers home why this small anatomical tunnel is literally a lifeline. The adductor canal isn't just some empty space. It is a critical vulnerability and a vital passageway, all at the exact same time.
Which leaves us with this final thought for the explainer. We've seen how just a single hidden tunnel in the thigh holds the absolute key to walking, and how the body can brilliantly engineer these life-saving detours around failing arteries, provided it has enough time. It's just an astonishing level of adaptability. So, I'll leave you with this question. If our bodies can build these incredible detours on the fly, what other hidden engineering marvels are quietly working beneath the surface to keep us moving every single day? Definitely something to think about the next time you go for a walk.